Cameraman. All right. So the square root of 9 is 3 simply because it takes two 3's to make 9. So a square root, a second root. There's an understood 2 there that we never write unless it's me doing that to show you. So like the cube root of 8, what does it take 3 of? 2. To make 8. It takes 3 2's to multiply to be 8. So it is sort of like division. When I divide by 3, if I do 6 divided by 3, that's 2. Why is that 2? Because what does it take 3 of to add to be 6? 2. I really want you with me on this, right? 6 divided by 3 is 2 because it takes 3 2's to add to be 6. The cube root of 8 is 2 because it takes 3 2's to multiply to be 8. So division is all about how many of these things does it take to add to be this thing? How many of these does it take to add to be this? This one is, I kind of said, what does it take 3 of to add to be this? What does it take 3 of to multiply to be this? It's a nice analogy. It's the same kind of question you're asking yourself. You're just using a different operation. So coming back to this, if the square root of 9 is 3 because 3 squared is 9, the opposite of the square root must be square root. If I square something, that's the opposite of taking the square root. Square root of 9 is 3. 3 squared is 9. So when I square, don't I undo the square root? Don't I get back to where I was? So then if I square both sides, that's how I would solve that equation. So the only thing that changes with equations are what's inside of them. And what does that matter to me? I've got to know the opposite of that stuff to be able to solve it. Yep.
So would the answer be x squared equals 49?
No. When you square a square root, they cancel. So x equals 49. 7 squared would be 7 times 7. Yeah. So I just got a hell of a lot ahead of where we currently are. I'm trying to make the point that it's going to happen to you. 103, 110. If anybody has to go further than that, you're going to learn even more functions. You're going to look at them in equations. Why the hell do we do that shit? Because in real life, we get any frickin' equation that wants to be in our equation. Any function. Who knows? Depending on what we're looking at. If we're looking at sound waves, anybody deal with sound at all? You ever seen that up on the oscilloscope? You see the sound waves, and you change the gain, and you can see it, and then it has this thing happen to it. Growl. If you've done sound, you know it kind of inverts the wave, and you're like, oh shit, I don't have this up enough, and that's no good. But if you're dealing with sound waves, you might have these, what's called, that sine thing I talked about earlier, that's a sine wave. You might have that function show up in your equation. So if you've got to solve it, you've got to know what the hell the opposite of this thing is. So real life can throw at us whatever the hell it wants to. So we're just here trying to get ready for that shit. Why do you learn karate? You might never have to use it in your whole life, but just in case somebody comes up to you and starts throwing stuff at you, you're ready to do something with that. It's the same. I'm not trying to say math is karate, but it's the same kind of preparation. Yeah. The math ninja. Right. Anyway, sorry. I go off on those things sometimes. So, I do not know if that helped out at all, but just to do a real quick example like what we would see. Alright. So if I had to do this problem, what would you guys do first? What would be your first step? I think you're saying maybe, but you were saying, what were you saying, Lindsay? I like it. So Lindsay's got one approach where she just wants to start putting the x's together, which is beautiful. There's nothing wrong with that at all. Or if you're kind of bothered with decimals and you don't want to see the decimals, you could start off by multiplying by 100 in this case, because I have to move it how many times? Twice to really kill the decimal. You with me? The reason we can do that is because I can multiply both sides of an equation by any damn thing I want to. And in this case, multiply by 100 is useful. Bless you. You with me? I could multiply both sides of this equation by 1.87 if I wanted to. Why the hell would I do that? I don't know. I'm not going to do it. So if I multiply everything by 100, multiply both sides of the equation by 100. Bless you. And why are we doing this? Does solving equations require me to do this? I'm just making the equation look better for me. The equation is like, whatever, dude. Right? The equation wants me to get my x's together, my numbers together, like Lindsay said. And you certainly could just go ahead and attack that. You should be able to. But it's not a bad idea to kill your decimals. Why not? Eliminate a place where we might make mistakes. So what do you end up with here? Beautiful. It goes once, twice.
25 and 40.
Yeah, exactly. Not 4.
40.
Twice would be 40.
30.
Oops. Minus 3x. And now that's this. Right now that should be no problem. So now you can like add the 3, add the 25, get your x's on one side, your numbers on the other side. But again, I really did not need to do that multiplication by 100, but it's just so damn useful. Why not? So there's nothing wrong with not doing that. You're starting to add. You can add 0.03 and get 0.20x. And so this is gone. And then you can add 0.25. I mean, it's the same steps. Just the decimals in a different place, so the math isn't here. You guys with me? So you could solve this equation, or you could solve this equation. I don't care. You would still, if you add 0.03x, what's 0.17 plus 0.03? 0.20. And you can add 0.25. What do you get there? 0.4 plus 0.25? 0.65. And then what's the last step here? Divide by 0.2. Cool? And that would be, of course, 3.25. If I solve that equation, I would add 3x, add 3x. I get 20x minus 25 equals 40. Do you see how that looks very much like this step? Just the decimals in a different place. That's why multiply by 100. You can do it or not. You can do it if you don't like decimals. If you want to make it look easier, you know, make it easier to look at. Add 25. Add 25. Do you see how the steps I'm taking are independent of if they're whole numbers or decimals? And the steps I'm taking don't change. Just the numbers I'm using change, of course. And then divide by 20. So of course you end up with the same thing. 3.25. Maybe. Yes, sir.
So if it didn't come out as a nice number like 3.25, if you had multiplied in the beginning by 100, would you have to then at the end divide by 100?
No. In fact, here I multiply by 100, didn't I? That's the step I took here. Did I have to worry anything at all at the end? If I get x by itself, I'm good. Notice this number came from being multiplied by 100. This number came from being multiplied by 100. So the multiplication by 100 cancels at the end. That's why the math doesn't care. Math is whatever, man. If I double an equation, at the end that doubling will cancel itself out when I take that last step. That's why I can do anything I want to both sides, except multiply by 0. You can't make every equation 0 equals 0. We would still be living in caves. So, maybe not that drastic. Anything else from the quiz? I went way off on that. I mean, this is huge. I think I said this a couple times in this class. If I can get you coming out of this class feeling decently comfortable solving equations, that is huge. You might pick up on the idea that that's basically one of the biggest things throughout all of mathematics. Because what is a real-life situation can be boiled down to an equation very often. And if you don't know how to solve equations, then you don't know how to solve real-life problems. And that's bad. Yes, sir. The last question. Oh, the rounding? Yeah. So the first step when I ask you a rounding question is, can you find the place that I'm talking about? Right? So if I have when I say round to the nearest tenths, what number's in the tens place?
Zero.
Beautiful. Zero's in the tens place. So I look to what?
Right number.
Good, to the 9, so that's got to go up
One.
to 1. So this would be 17.1. Now for some reason I get people that would do this. Now I understand where that came from. You're worried that you're losing things, but that's the whole point of rounding, is to lose stuff. I don't want to write all that crap out. So this is, not only is this still look bad, but it's also very wrong. That can't suddenly become 17.1942. That doesn't make any sense. Or I get this, which is not wrong, it's just not necessary. Right? I can stop at the place I'm asked around at for these decimals. What if I say tens?
7, first 7.
What's in the tens place?
7.
No, 1.
1 is in the tens place. 7 is in the ones place. Right? So this would be tens. So that tells me to take this up to... Yeah, now don't put 2 there. 20. But I do get that sometimes too. People get a little focused on that number by itself. 17 is not about 2. 17 is about 20. Notice that everything after becomes zeros basically, right? So that becomes a 2 and that becomes a 0. Is that cool? Is that... Did you ask that question? Who asked? Okay. Over there, someone. Is that your... Does that help? Okay. No memory. Alright. And the first part was just adding and subtracting and multiplying, so that should have been hopefully pretty straightforward. Okay. So what we're doing today, we're going to finish out chapter 6. And we really just have 2 sections left, and I really kind of got us into section, now I forget the number, 6.4? 6.3. But I want to do a few examples. This is page 427. So look at number 4, for example. And I want to be careful. One reason why I want us to look at these problems is so that we understand where the problem actually comes from. If you read the italics above that problem, what does it say?
It takes the word process at 30 minutes. The word process and process 4 pages.
So it takes 30 minutes
Over 4.
for 4 pages. So John says a really good way to write that is 30 minutes, 4 pages.
So x over 4.5. Or no, 4.5.
Let me catch up to you. Now, you could, it doesn't matter which way you do this. It doesn't matter which way you set this ratio up. As long as, if you're going to make a proportion, now, can somebody help me out? This is a ratio. Cool. What's a proportion? How do you create a proportion?
30 to 4. 4 to 30.
That's still another way to write a ratio. So a proportion would be the equality of 2 ratios. And that's where that cross multiplication comes in, right? So if I say 1 mile is takes me 4 minutes to do, 2 miles would take me 8 minutes. That's a proportion. And it really, if you'll notice, it really is truly just reducing or increasing fractions. Really all. This ratio must remain the same. And if you cross multiply, what do you get? 8 times 1 is 4 times 2 is. So it is a true equation. And we knew that because 1/4 is 2 8. Jeff, what the hell? What a big deal. But on this side, there's a part of this that I don't know. What part do I know for this other side?
4.5 on top.
Hours.
Yeah, number 4 says, how many pages can she word process and spell check in 4.5 hours? Now, can somebody spot, now, I wish they wouldn't have done this, but they did. Can somebody spot a slight problem? How does this one have to be set up, considering how I set this one up?
You have to change it into minutes.
I like it. So this one has to be minutes to pages, so this one must be minutes
You have to change 4.5
to pages.
So
So 4.5 hours, how do you tell how many minutes that
60
has?
times 4, and then add 30.
Yeah, since every hour has 60 minutes.
60 times 4, and add 30.
4 hours would have, 240 minutes.
Then add 30.
And then half an hour, of course, is 30 minutes. So 270 minutes. So, or in your calculator, like John said, you can just take 4.5 times 60. Because every hour has
So
60
that's the
minutes.
mistake that some people might make. They see the ratio or whatever, minutes, and they don't change the hours to minutes.
Exactly, you could do that. You could also just change the minutes to hours. What would be kind of gross about that is you'd have, 30 minutes is how many hours?
Fraction.
Yeah, you have a fraction inside of a fraction, which we'll actually see anyway. If you have a choice, why go that way? Let me just stop right there for a second. Make sure everybody's semi with me. In general, the setup of proportion, you come up with a way to set this first guy up. You're always going to be given information. My car gets 28 miles to the gallon. So that's 28 miles over 1 gallon. Or I make $17 every 2 hours. So that's $17 over 2 hours. You guys kind of, I always give it information. And then it says something like, well, I worked 28 hours. How much money can I get? So I get another ratio that I'm missing something. And of course, that's algebra. Little x goes there because I don't know what the hell it is. So now we figured out that's 270 minutes. And the question is, how many freaking pages can I do? So now you could cross multiply, or you could actually be very smart about this. And you can say 30 times what is 270? So 4 times 9 is 36. Okay, now just keep that in mind, because that's not always going to be easy. That's not always going to be easy to do. So let's do this the way you should just do this in general. How would I do this in general?
I multiply 4 times 270.
Good. Cross multiply. The x comes up 30 times x, 30x. 4 times 270. Cool. and now how do you solve that?
Divided by 30.
Come on. So again, the steps were, you're always going to be given one piece of information. You're going to be told, for every 3 kids, you want 4 adults. You're going to be, 3 to 4, whatever. You can set that one up. And then they're going to give you, well, if I got 20 kids running around, how many adults do I want? So you're going to have something where you know part of it and you don't know the other part. You want it to be set up the same way. So let's finish this one out real quick. When you divide by 30, what do you get? 36. And that's exactly 30 times 9 is 270. 4 times 9 is 36. You could do it that way too. So 36 pages. Now I said earlier, I don't know if you guys caught what I said earlier, I didn't have to write it this way. In fact, that's not really the way we'd say it in English, is it? I'd say more like 4 pages per half hour, 4 pages per 30 minutes, right? So if I did 4 pages every 30 minutes, where does 270 go?
On the bottom.
Yeah, I've got to have minutes on the bottom. So 270 minutes, X, pages. You can still cross multiply if you want to. Here you actually just need to multiply the 270 to get the X by itself, so you can be a little smart again. The cross multiplication is a shortcut, and very often shortcuts miss other things. I mean, bring that up. Why the hell would I want to bring that up? I've already had X by itself. But you can always cross multiply if you want to. You'll end up with the same equation. You end up with the same answer. Yay. Let's do another one. Yeah.
You write it somewhat simply and say something like you divide 30 by 4 and find out if it takes that long to check each page.
Sure.
And then multiply that times.
I like it. I like it.
You can do that on like a test or quiz or something.
Exactly. So right here you could see 30 divided by 4 to get a unit thing. To see what does it take one page. So if I divide by 4 on the top and bottom, wouldn't that be so much time per one page? And then you can go from there.
Mm-hmm.
That's fine. So I'm going to show you the most general way to do things. But very often there's a more clever way to do it. A shortcut way to do it. A quicker way to do it. Right? But cross multiplication will always work. Always. Let's try another one of these. Look at number 11. Little Honda Civic Hybrid. So it says it gets 627 miles on 12.3 gallons. Right. It gets blown over when the Hummer drives by or something. Basically polar opposites. But what is it that I don't know? What does it say? It says Manuel Lopez is planning a 1,250-mile vacation trip. How many How many gallons of gas can he expect to burn? So I don't know how many gallons he can expect to burn, but I know he's going 1,250 miles. Right? So how do I set that up in a proportion? What's the first ratio I can make here?
627 over 12.3 gallons.
I love it. So it takes 12.3 gallons to go 627 miles. I want to go 1,250 miles. How many gallons will that take? And then you can cross multiply. So this whole section, once you see a couple of these, the section sets itself up. They have to give you a full piece of information, a full ratio. And then they say, okay, here's another thing, I'm just going to give you half the information. That's where algebra comes in and says, let's put an X there. Solve it. So to solve this, what would you do? Yeah, good. Bring that X up there. So X, 627X, I'll do that side. What's 12.3 times 1250?
15,375.
Do it again?
15,375.
15,375. And of course, divide by 627. So on the scale of equations being difficult, not. Right? It's the getting used to how to set it up, and even that I'm hoping you guys see is not difficult at all. They have to give you all the information you need. So here I divide by 627. So X is whatever the hell that is.
5215311.
Do it again.
24.5215311.
521.
5311.
Blah blah blah, and it says round to the nearest gallon. I like it.
Gallon. So I'd say
25.
gallons.
Good. 25 gallons, and that makes sense. I'd say always round up, just to be conservative. Right? Multiply by $4 a gallon because you have no idea where the hell what's going to be like where you go. Okay. So let's do section 6.4, and then I'll give you guys a few problems to try out. A lot of people have moral problems with 6.4, so they have to leave 6. The 6.4 is all about square roots. And actually, I'm going to go a little further than square roots, just because I do that sometimes. But the basic idea of a square root. So what's the square root of, you can do it, Jeff, 81?
9.
9. And again, why?
9.
Because 9 times 9 is 81. So square root is a good example of a problem, an operation where I got to think backwards. What does it take 2 of to make this? Square root of 81 is 9. Now, what do you think about this?
Negative 9.
What's negative 9 times negative 9?
81.
So there's 2 kind of things that come out of that. Then what the hell is that, Jeff? And also, one other thing that should be troubling you is, why is the answer here 9 and not also negative 9, right? And the problem here is, the second one I can answer really quickly. This is called the principal square root. Every number has really 2 roots except for 0. 0 is 0 times 0. But 4 is 2 times 2 or negative 2 times negative 2. So if I want the negative one, I've actually got to say I want the negative root. Since the square root of 81 is 9, the negative square root of 81 is negative. I have to be very specific to get the other possibility. You guys semi with me? How many things can I multiply by itself to get 25? 2 things. 5 times 5, negative 5 times negative 5. So I have to be very specific which one I want. Whenever you see square roots in by itself, that's the positive answer, period. The second part is, okay, Jeff, that sounds okay. I got that. What the hell's that then? This is not, you'll like this answer.
Not real.
Not real. That does not mean it's undefined. That just means you haven't learned what it is yet.
So the negative sign has to be on the outside of the square root?
I love it. And again, the whole reason the square root cannot handle a negative on the inside is because there are no 2 real numbers that can no real number I can multiply by itself to get a negative. Because if I multiply them by itself, automatically they're the same sign. And I can't get a negative out of that. You can get a negative out of something comes to itself if it's not real. And there are numbers out there that are not real. Yay!
It sounds like it's
They're called imaginary numbers, and you'll learn about them starting next semester. And y'all, I know the minute I say that, y'all like, all this shit is imaginary, Jeff. You probably make it up every day you come in, you know, whatever. But since I said that, I really want to make you guys understand. Like the square root of negative 1 is not real. But I very often in problems get this solution. And if I just throw it away, I might actually lose something. In fact, I don't know if I can take you with me here, but in physics very often, this answer means something. Because it kind of keeps track of, you know, you have magnetism and you have electricity. You know they're kind of related a little bit. So in physics, very often the electrical part will be the real part, and the magnetic part will be the imaginary part. So if you just threw this out, if you just threw that out entirely, we wouldn't have a freaking clue about magnetism. We wouldn't be able to do anything with it in equations, do theories and stuff. How important is that for this class? Not. But I desperately want you guys to go in, not with the perspective of, okay, imaginary freaking numbers, what the hell else are you going to throw my way? Right? They actually have a purpose. They make the whole thing kind of cohesive. I don't want to just throw something out. I want to really look at it and say, does it have something, does it mean something somewhere? And yes, they do. That's why we eventually will talk about them. I wish they would not have called them imaginary. It's a stupid-ass name, but I wasn't around. So for us right now, this, you just say, not real. This is fine, just like it's been fine forever. That's 9. That's negative 9. See, that has nothing to do with the root. The root's happy. It's got a positive dude in it. So let me throw you a little weirdness. Can somebody estimate what that is then? Give me an estimate. Because it ain't nothing whole, right? Just to use some awesome grammar.
9.25.
Yeah, you know it's a little bit above 9. So I like that. So 9.2 maybe? Now take your calculators out. Do you see where your square root button is? Very often it's like, well, here it's got its own button. Ah, very nice. So if you do the square root of 85, some of you guys have to put 85 in first and then hit a square root button. But some of you guys, most of you should be able to hit the square root button and then put 85 in. So it comes up to be what, 9.2?
2-1.
1? Well, I like this. It's my birthday. Very strange. Are you guys, that was damn good estimating. So estimate what would square root of 53 be then, roughly? What number is close to that you could do the square root of?
7.
Well, 49, which is 7. So square root of 53 should be
7.28.
7.2 something. And if you do the calculator, you get
7.28.
7.28. Yeah. All right. So obviously, to do that kind of problem, you have to understand 49 is out there. It's important. And those numbers are called, let me put this down, close to, this is called a perfect square. Because it's the square, it's a number that is the square of an integer. Of a whole number, right? 9 is a perfect square because it's 3 squared. 10 is something squared, but it's not the square of it's not the square of a whole number, so we don't call it a perfect square. You guys with me so far? Yeah, you're looking at me so intently. So I want to take just a second and go a little bit further than the book does. And I know I've done that already many, many times today. And I've already actually done this. What do you guys think the cube root of 27 would be? 3. I love it. So it's not 27 divided by 3. It's what does it take 3 of to multiply to make 27? 3 times 3 times 3 is 27. So since I can break this up into 3 times 3 times 3, it takes 3 3s to make 27. That's why the answer is 3. You guys semi with me? So how would you approach this then?
3 fours.
Could be 3.
So what does it take 4 of?
3.
Yeah, so 81 is 9 times 9. So the square root of 81 is 9. We saw that one earlier. But if I keep going, it takes 4 3s to make this. So the answer to this would be 3. Because it takes 4 3s to multiply to be 81. You guys with me? We're actually only going to see square roots in this class. Math 90, Math 103, 110, you're going to see all kinds of figure roots. Here we just kind of start with square roots, but I want to give you a little preview because it's the same idea. This keeps going. It's the same idea. Oh, let me say this thing about this. Help me out. What's negative 3 cubed? What do you get when you do that? Negative 27. So notice something interesting. What is the cube root of negative 27 then? What does it take 3 of to make negative 27? Negative 3. So see, cube roots don't have a problem. Square roots can't handle negatives. You with me? It comes out not real. It comes out imaginary. Oh shit. Cube roots, you're like, whatever. Because if I have 3 things and it's negative, doesn't a negative stay alive? 2 negatives cancel. The minute I have any even number of things, all the negatives cancel. So any even root can't handle negatives, but every odd root can. Just because of that simple fact. And we all know that. If there's 3 negatives, the answer is going to be negative when you multiply. We know that. But this is a nice application of that idea. Again, how much will we see that in this class? Not at all. I just want to get you ready. So this is actually negative 3. Do not say not real. Because odd roots are cool. They're laid back. They can handle negatives. Okay. So one last thing, and then I'll give you a few problems to try out of the blue book, I think. I can't remember, I think I drew this up here once before. One of the, again, there's so many weird facts about math. One of the Roosevelts, you know we had 2 President Roosevelts. One of them, I can't remember right now off the top of my head which one it was. In his spare time, he did like 53 proofs of the theorem that we're going to talk about right now. There are many, many more than that. And I want to show you one that's not really a proof, but it's a neat visual. Anybody know what the hell I'm talking about? What relationship is there from this? What kind of triangle is this?
Right triangle.
Right triangle, okay, because it's got a 90-degree angle. What do I know about the sides then of that right triangle?
It's a hypotenuse.
I love C's hypotenuse, right? But beyond their names, what do I know about how they relate?
Now you add A plus B equals C.
Not quite.
A squared plus B squared equals C squared.
A squared plus B squared. Let me put this away. Does that sound familiar at all? Old Greek dude? Exactly. And of course, Pythagoras had this big group of followers who did all his work for him, and then he took all the credit. Well, he did something. We give him a little leeway. History and math is really funky. But here's a really cool visual. If I draw a square here, which means it's A by A, what's its area? A squared. You guys see where I'm going now already? Here's this B squared, right? Try to be a square. All right, Jeff, just stuffing OCD. So this will be B squared, and this will be C squared. You guys, so if I add that square's area to that square's area, I will get that square's area. That's basically all that says. Doesn't matter which side is A and which side is B. No. As long as you get C, the longest dude, the guy that's across from the biggest angle, which is why he's the longest. If you have a big angle across, you can go further. Little angle. So what's a problem you're going to see? You're going to see this kind of problem. Oh yeah. I'm going to say find X. And of course, this is the one where you go, X is there, Jeff. Next question. Right? That's on the thing. I got to be careful how I add. So say find the value of X. What's C?
X.
C is
No.
25.
25. 25 is across from the right angle. So I can call that A and that B. It doesn't really matter. I just now got that side squared plus 24 squared equals 25 squared. So what were we just talking about earlier that actually is happening sooner than I remembered? We have to solve an equation now with a square root. We had a square root earlier. What's the opposite of squaring? Square rooting. So the first step here is to do those squares, right? Good old order operations. 24 squared. Is that 576? And 25 squared.
625.
Cool. Subtract. Good. Subtract 576. 625 minus 576.
49.
49. And of course, what squared is 49?
7.
7. So I'm taking the square root now. The dude is I take the square root of both sides. I know it's positive, so I just take the positive one. It's not negative. It's a length. So that's 7. So far, so good. So here, you guys do one. I want to show you. I purposefully chose sides that would make that side come out nice. That side definitely does not always come out nice. Because it's square roots. I have to make it so that it came out to nice 49. So what if I gave you this one? Find how long the hypotenuse is. What's X?
C.
40.
Good. X is C. Now do it. Almost, John. One more step.
6.
Go the other way. Don't square it, get square root. So how do you set up this equation?
2 squared
2 squared
plus 6 squared
plus 6 squared
equals X squared.
equals X squared. I love it. So then you get
36.
so 40 equals x squared. See, those cancel. That's why I take the square root, so I can kill that square. I want to get x by itself. I want to kill the square, so I take the square root. I do the opposite. So x equals square root of 40, which is 6 point something, right? Because 36 would be a perfect 6. So you get 6.324, blah, blah, whatever. So I'll tell you where to, I think in the book and on my test, I'll tell you where to stop, what's around it too. But there are certain triangles, like there's a 3, 4, 5 triangle. 3 squared plus 4 squared, 9 plus 16 is 25. 5, 12, 13, 7, 24, 25.
That's how you get an exact right angle, right? Like with the tape measure.
Exactly. I love it. So you can measure out 3 that way, 4 that way, make that 5 actually fits in there, and then this will have to be a right angle. I love it. Or you just use a big old protractor. or a T-square. Right. I think there's one. Going back for a second before I unleash you on a few problems. What's the square root of 1? 1. I like it. In fact, what's the cube root of 1? 1. What's the 800th root of 1? All right, good. What's the square root of 16?
4.
So what's the square root of 1/16?
1/4.
I love it. See, not a big deal. Right? If I would have given you that problem first, I'm almost certain that some of you guys would have been like, I don't know what the hell. But it's all it is. Square root of 1 is 1, square root of 16 is 4, so square root of 1/16 is 1/4. Not a problem. So with that in mind, do these problems out of the Blue Book. Page page 106. Let's see. Number 10. And page 111. Number 5. 14. And 19. If you didn't bring your blue book, cozy up next to somebody who did.
Oh, 106.
So right here, so they always kick in when you need to start. $625 tax or $100 purchase.
Instead of tax to purchase ratio.
625 or 100. I need to tell you something.
I wrote $500.
Tax.
No, you're good.
Now, what do you know in the situation we're in? The refrigerator costs $550 to purchase, right? Where's that $550 going to go? Because what goes on top? The tax. So here's find the tax. So I don't know what the tax is. X over time. So the thing to really get is, once you set this up, you're saying the tax has to be on top. Purchase has to be on top. So I don't know what the tax is, that's X. But I do know what the purchase price is. So now you can cross multiply if you want to. And 100. Yes, so that's sure. The 100 comes up around that. And be careful, I think there's a decimal here somewhere. Oh, be careful, 6.25, man. Yeah, 437 So now one step and you got it. Good. Good.
Exchange equals 100 minus 6.
Oh, and you copied them all down?
Yes.
Okay.
That makes sense because if you round it up, 9.2 squared is
'Cause you cancel this plus 16, you should subtract 16.
Oh.
Yeah, so if you do 91 squared,
Go on this one more. Ratio is 90, I'm not sure. But this is what you don't know.
2 over 100.
$6.25
So that's be 6.
for every
How
100.
less?
This is the tax
10.
on that much of the purchase. So when they give you a complete set of information, you make a ratio out of it, regardless of the square meter. This is what they told me equals. I still need tax over purchase. What is it that I know? What is it that I don't know? Where's the 550 go? Was that a tax or was it a purchase price? Yeah, so I go there, and then asking me for tax. Why did you make this? Okay, I see what we're doing. So 6 times 100 is roughly this. So 6 times 6.25 is. But then you got to subtract out there. So 6.25 is 50. But you're doing a lot more than you need to. It'll work. You're doing more than you need to. No, so where's the 30 bucks?
Is the long side.
We actually so now what you do is you average those. Yeah. Average them. And that'll be the because if you do 5, you do 6, but what you really want is 5.5. Yeah. You just average those.
So minus
average them. But that way works, but it's more than you need. Yeah. Especially because we're allowed to use calculators on this. So let me try to catch up to you a little bit. Like I said, they always have to give you a situation where everything is known. If I buy $100 worth of stuff, I got to pay $6.25 sales tax. So the top is tax, the bottom is purchase price. So the minute I set that up, I've told myself what any other ratio has to look like. Now what is it that I don't know? The tax. So I got to put X tax. I have no idea how much tax I got to pay, but I do know that the purchase price of this thing is $550. So they must give you a complete set of information. They must give you something where you can make a complete ratio. And then you make your incomplete ratio. You put X in the spot that you don't know. And then you just solve that. Say, take eyes out. Happening math. So how do you solve this for X? A few different ways you can do it. Yeah, you can cross multiply. So I get 100X equals whatever that is. Nobody's going to help me out?
34, 37.5.
3.
437.5.
Okay, sounds all right. And then to solve for X, I just have to divide by 100. And we know the shortcut for dividing by 100 is we just take that decimal back twice. So we 34.375. Did it say around anyway? Yeah. So it's about $34.38 tax. How we know so far? Is that decent? Okay. And that's basically how almost all of our proportion problems are going to run. Some of you guys might realize or know from before there are other ways you can set this up if you really want to. where you just always set it up. They tell you a complete thing, and then they ask you something. And you set up the same format. What about this guy? Yeah, good. Once I did that problem, this is easy. Square root of 49 is 7. Square root of 64 is 8. So 7/8. Square root of 20 is in between what two numbers?
4.
Good. 16, square root of 16 would be 4. Square root of 25 would be 5. So it's in between there. So a good guess would be 4.5. Why not?
That's close.
And what does it actually come out to be?
4.47.
4.47. Not too bad, right? And then finally, this guy. This is a cool, well, not cool, but it's an interesting real-life problem, and you'll see this a lot. The ladder against the building. We like that problem for a few different things. So ladders against the building. Ladder's 10 foot. It's 4 feet away from the building. So how tall is this building? It's a very. It must be a shed. I don't know what's going on here. It's not going to be very tall. But how do I set up the equation? What's the most important side? 10, because that's hypotenuse. It's got to be by itself. So you'd say x squared plus 4 squared equals 10 squared. Then 10's got to be by itself. So at x squared plus 16 is 100. Squared is 84. So x is the square root of 84, which should be a little bit above 9, because 81 would be 9. So what do you actually get?
9.165.
9.165, roughly. I could live with that. Alright, so that's plenty. So on Thursday, I will have both the practice test. We'll actually end up doing that in class together, and then I'll have the answer key also. So if you're going to miss Thursday, you probably want to email me. I can send that to you. Next Tuesday, of course, is the test. Cool. I'll have the quiz. The quiz is graded too then. Oh yeah. Well, the quiz always comes from like a week ago. Last time we got into 24 and 6 with setting up the portion, the ratios, and all that stuff. Yeah, that's what we did last time. The time before that, we finished out chapter 5. Yeah. I think we did. On the homework sheet, it says you actually don't do 5, 2, 5, 2, 5, 4, anything out of your sections. You do just this page 367. Yeah, you don't have to do any. I think you did problems out of 5, so you didn't have to. I want you to just do this one. It's just the quick review over all of this stuff. Hopefully, you haven't done anything out of 5.3 or 5.4. So you don't have to. You just have to do that review.
Only the review?
Yeah, on the sheet, exactly. Because on the homework sheet, I just have stuff from 5.1, but then I just have stuff from 5.2 through 5.4 out of that review. You with me? You don't. There's no problems in. You don't have to do any problems in 5.3. You don't have to do any problems in 5.4. You just have to do this.
Okay, but this one is 5.2. I don't know whether
Yeah, 5.2 also. It's not on the homework sheet. There's like the homework sheet says 5.2 through 5.4, and it says page 367.
Oh, so I don't have
just that review. You don't have to do that.
You didn't?
What do you mean?
I did 5.3, 5.36.
Why would you do that to yourself?
Because it said 5.2 through the little dash number.
I know, but then it says, what does it say next to that? Page 367.
Yeah, but I got the every. Oh, look here.
No, come on. So page 367 is a review that covers all of that. So that's why I have that goes back. Well, you got extra. Nothing wrong with that.
Yeah, but
I like it when students do that themselves.
5.2 and 5.4 would be explained in class. So all I did was the review. Because this covers everything in that section.
Oh, here's thousands. Yeah, it should be 4.472. I like
This
it.
one, see?
I didn't pay attention to what the.
I was like, did I misunderstand?
I forgot they said round it all. So I was just going with the cloud
Yeah,
source.
just do this one. Yeah.
Thanks, guys. See you. Oh, is that your water there? Somebody?
No,
No?
that was there.
Oh, that was there? That's
Yeah.
complimentary? All right.
Yeah.
Yeah. I don't think I'll take it.